All right, Eli here again. This video, we're going to take a look at basically getting set up with the example code for the Frdm Tfc board. So on the community's website, under Frdm Tfc, you'll see a little 3D rendering of the board. We'll get a picture up. What I'm going to show you today is kind of how to get a hold of the example files and get them imported. We're not going to do anything with them today, but I'm just going to explain what it does and how how you can use the examples in some detail. So if we go to our code examples, I'm going to click on the link here, and all of the code is stored on a Google Code open source kind of repository. I use Subversion. So you might want to get familiar with a version control system. That way you can actually check out the code. And if you get a hold of me, emh203, at gmail.com. If you want commit privileges, you could make your own improvements. So now, certainly, excuse me, peanut. Certainly, if you want to check out the code, you can get something like Tortoise SVN and just grab a copy. The other thing I'll do periodically is in my Subversion structure, I have tags. Use a tag folder. I'll try to put up static releases. So I have release R0. I'll just number them like R1, R2. So R0 is kind of like the first working reference version. So we'll just grab that real quick. And what I'm going to do is let me drag this to my desktop first, then I'll move it somewhere else. And I'll move it into, where's R0? There it is. My Freescale demos folder. All right. So let me close that. Let me close that. So I'm going to import existing projects into workspace. Browse. We'll just look in R0. Yeah, we see our project here, and it's just called Frdm Tfc. So a couple things I'll mention to you that'll make it easier if you want to move the project around is I'm going to open up project headers and sources. So everything there's a TFC folder in project headers and sources. I considered putting them just in the sources, but I would figure I'd keep with the Freescale way of doing things. So if I go to sources, TFC, there's all the source code. This library, and if I go to headers, there it is, TFC. So if you were to make a new project, all you got to really do is copy in the TFC folders for the headers and the sources, and you're almost ready to go. The other thing you need to do is, because you notice project headers TFC, it's kind of buried, one folder in. If I go to tfc.h, that's like the global include for, all of the other files. You notice here they are. So sometimes, depending on where you put those folders, you may have to go in like C++ build settings, and that's fine. That's the assembler. I want the compiler. You may have to add, another include path for it to get to it, but I think everything should just kind of work out. So I'm going to do build all. And let's give it a minute to build. All right, no problems. That's good news. Now, what I'm going to do is just give you a quick overview here of kind of what's, how things are organized. So I'm just going to go to my main function, and to use the this kind of like library, you know, if you want to call it that, you basically just need to include tfc.h. But you notice how I included this relative path, tfc/tfc.h. That way I didn't have to include any extra directories, because by default it's going to look in project headers, then it'll look in tfc, tfc.h. Well, tfc.h simply just includes all the other, include files we kind of need. And so what you can do is you can kind of look through the file names here and see, you can kind of get an idea what things, the motors, to control the motors, line scan camera, has some line scan camera code. You can kind of get an idea of how things work. Now, the API here is fairly simple. It's not well documented yet, so I haven't quite settled, but you'll notice as you go through it, I kind of do things the same, in each function in terms of the API. For example, the potentiometer, when you read the potentiometer, I scale it from, the value from, the return as a float from -1 to 1. Well, the servo, my servo function takes in a value from -1 to 1. That it'll, kind of move the servo and always use that normalized range, and so does my motor. So that can make things, it uses a little bit more CPU cycles to process those floats, but if you're just getting started, it kind of makes an easy way to, see how things are working. So now let's go back to main. So there's only a couple things you need to do here, and is to kind of make things work. I have a function called tfc init that has to be called, pretty quick after main. And so if I go under tfc and look at tfc init, all it does, it just calls a bunch of other initialization. I initialize the clock on the board, the systic timer, GPIO, servos mode. You can kind of see how this works. So if you add anything, this is kind of a way you can do it. Add it to tfc init if you need to initialize something else. Then I just go into the main super loop. So this is just a classic super loop. Now, one thing I do, you may not need this function, depending on what you use in the library, but it's a good idea to call it. It's called tfc task. It's just a short little function that immediately will enter and leave, and it just does a couple little things. There's a couple functions dealing with the terminal and the serial port that they just need periodically call to check queues and whatnot, and that's what tfc task is. So if I go to tfc, basically the UART process in the task just checks to see if there's any stuff to be moved out of the queue. And then the terminal has some logic that needs to be executed. And we'll talk about the terminal and whatnot later. Now, the demo mode, I'm going to go into other videos, kind of what the demo mode is, the 4 demos. But let me just kind of show you the structure of this code. I have a function called tfc get dip switch. So let me bring over my little webcam here. So on the board, there's like a little 4-position dip switch. And generally, on all these TFC boards, I've been having 2 push-button switches, 2 dip switches, a 4-position dip switch, and 2 pots. All right, just for your reference. Now for the dip switch, what I do, and this might look a little funky if you're not quite used to C code, is, and there's a historical reason for this as well, I look at the middle 2 switches. So TFC get dip switch returns a number that has the lowest 4 bits are, the switch settings. So I use the middle 2 bits 1 and 2, 0 and 3 I don't use right away, to select one of 4 modes. So you notice I take the return of this function and shift it over by 1. So that takes bits 1 and 2 and makes it bits 0 and 1. So I get a number between 0 and 4 made from the middle 2 switches. And then I do an AND mask. I mask out the upper 2, the bits that are left over. And then I just switch on that. So that'll, those middle 2 bits will then turn into a number between 0, 1, 2, or 3. And then I just, have 4 different cases. Case 0, case 1 for demo mode 1, case 2 for demo mode 2, and case 3 for demo mode 3. So, like I said, use this, just look at my comments here and kind of use this to get an idea of the API. I don't have like formal documentation on it as of yet, but if you just kind of read, just kind of look through the code, you'll kind of figure it out. Demo mode 1, in the other video I'm going to show off the demo modes, just kind of lights LEDs, but that should be enough to get you started. So once again, you just need to include, if you have copy this stuff to a new program, include TFC, TFCH, you need to call the init, and the task, if you're going to use a serial port or the terminal, it just has to be kind of in a loop there, continuously called. So that'll be it for this video. I'll have some other videos, and we'll discuss, dive into some detail of how the demo modes work.